This is systems of three equations, and we're going to use the elimination or addition method to solve these equations. So what we have to do is use all the equations, all three. So I'm taking the first two, and we're going to look at them, and then we're going to take the last two and look at them. You can use any combination you want, but you must use all three. So you could do 1 and 2, and then we could also pick 1 and 3. That would include all three. Okay, but since we have these set up the way they are, that's what we're going to use. Alright, so we're going to look at them. If you look at the first ones, the easiest ones to eliminate would be the x's. If we multiply this one by -2, we create a common multiple of 2, where here the common multiple would be 20, and here the common multiple would be 6, so it's easy to get rid of the x. So we have 2x minus 5y plus 3z equals -1. Negative 2x minus 8y plus 4z equals -18. Add them up. Negative 13y plus 7z equals -19. Okay, now since I got rid of the x on this one, I have to get rid of the x on this one. It's also the nicest. So I'm going to multiply the bottom one by -1. Make sure you change all the signs. And now we can add them up. Okay, so now you've noticed we've gotten rid of the x. And now we're going to take these two equations, go back to our original, and this is just to keep it organized, to show you what's going on. Alright, so now we're going to get rid of either the y or the z. Now this looks like it's going to be massive, so let's go with the z, which would be 14. So, move this back center. If we multiply this one by -7, and this one by 2, we would get -26y and then -42y minus 14z equals -14 times 7. I just don't want to take any chances. 98. And double check our signs. Negative, positive, negative, 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 negative. Yes. Okay. Add them up. Those cancel, and we get -68y equals 136, and there's your equation. So we come back down, take that equation, I've got it set down here. Make sure I wrote it correctly. Perfect. Solve it, which gives us y equals 2. And this is why we back substitute and we have it written. So now that we have y equals 2, you can take that and plug it into either of those. So just pick one. I'm going to pick the bottom one. 6y plus 2z equals 14. So 6y plus 2z equals 14. Plug in the 2. Solve it. So z equals 1. And then we go back and we pick any of these. So I like the middle one. I'll pick that one. X plus 4y plug it all in. And there it is. So our answer is 3, 2, and 1. That's our x, y, z. And how do we know we're correct? We have to double check it by making sure it's true for each equation. So if we multiply this out, 2 times 3 is 6. 5 times 3, 2, 1, right? Yes. That's -10 plus 3. and that would be 9 minus 10 is negative 1. That's 3, 8 minus 2. That's 11 minus 2, which is 9. And then again, 3 minus 4 minus 4. And that would be negative 1, negative 4 is negative 5. It checks for all three, and that's our answer. So to go back over everything, you pick one letter, x, y, or z. Use all three equations to eliminate one of the letters. And then you end up with equations that's just two letters. And this is just like our normal systems of linear equations that we would normally do. Just like the normal substitution method or elimination method that we did before. Alright, and so after doing that, it gives us one of the letters. We can then take that and plug it into either of the equations, which will give us a z, and then we'd have two letters, which we can then plug back into any of our original equations. So once you get to 2, you plug it back in, take those two numbers, and plug them into one of the previous original equations. And that will give you all three. So it's eliminate, eliminate, solve. Let's do one more, just to show you how to do it. So it's all set up. Okay? So we're going to take two equations. I'm looking at it, and let's see what letter should we do. Let's get rid of z's this time because they look nicely done. We could also do the x's. Y's don't look nice. Let's do z's, and we'll do these two and these two. So let's take our first two. X minus 3y plus 2z equals negative 4, and then 2x plus 5y minus z equals 9. And then the other one, 2x plus 5y minus z equals 9, and x minus y minus z equals negative 3. Alright, so we're going to get rid of the z this time. So this one is good, but this one needs a 2. And that would give us our least common multiple, which is 2, and 1 positive, 1 negative. So x minus 3y plus 2z equals negative 4. And that would now be 4x plus 10y minus 2z equals 18. The reason I'm doing all of this is to stay organized. If we make one mistake, we've got to go back and find that mistake. So if it's just gibberish written everywhere on a piece of paper, then you're not going to be able to find it. But if you take your time, keep organized, everything should work out fairly nicely. Okay, and then down here, we just need a negative 1 on that one. So 2x plus 5y minus z equals 9, and then negative x plus y plus z equals 3. Add them up. Okay, and then there's our two equations. So we have x plus 6y equals 12. And then 5x plus 7y equals 14. We look at them again. The x's LCM would be 5. These would be 42. So we're going to go with the x. So we multiply this one by negative 5. And that gives us 5x plus 7y equals 14. And then negative 5x minus 30y equals negative 60. And this is our last one. So we got rid of the z's. Now we're getting rid of the x's. And all we're left with is y's. So that would be 46. Divide by negative 46. Divide by negative 23. Actually, let's solve it down here, just so that we have it organized. So negative 23y equals negative 46. Negative 23y equals negative 46. Divide. And so we have y equals 2. We go back. Which equation do we like the most? I like that one. So the x plus 6y equals 12. Plug in the 2. X is 0. And then we go back to the original equations. And I like the bottom one. Plug in our values. 0, 2, negative 3. So that's minus 2 minus z, add the 2, and there it is. So we have 0, 2, and 1. And just to make sure it's correct, we have to check it. So 0, 2, and 1. This time we'll plug them in. That's why we have extra space. So 0 minus 3 times 2 plus 2 times 1. That has to be negative 4. And then 2 times 0 plus 5 times 2 minus 1 has to be 9. And then 0 minus 1 times 2 minus 1 has to be negative 3. So let's check this out. That's negative 6 plus 2. It's negative 4. Check. That's 0. So that's 10 minus 1. Check. Negative 2 minus 1. Check. It has to be checked for all three. So we could have gotten rid of the x's, but we chose to do the z first. So we got rid of the z, and now we have just x and y. You take those two equations, eliminate one of the letters. We chose the x, and that leaves us with one letter that we can solve. Plug it back into here. Take those two letters then, plug it in here, and it gives you your answer. And that's systems of 3 equations. Now, you may have been asking, what are these pictures up here? These are the 3 different ways that you can actually have solutions. So if you look at it, these are planes. You have 3 letters, they're 3-dimensional. And they could intersect at one line, which means we would have an infinite number of solutions. And the same rules still apply as before. And you could also have one solution, which is what we're getting, and you could have no solution where they don't intersect. And these will still come up with false statements. These will come up with true statements. And this will come up with an actual answer. And that's everything. Thank you.